Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz and as ever, I am the IT Geek. Welcome back to the AZ700 series. We are almost coming to an end of Module 2. We are partway through the cross VNet connectivity, implementing and designing cross VNet connectivity topic. So the last episode, you remember we talked about user-defined routes. We also talked about NVAs, which we're going to still touch on that again in the next couple of episodes as well. And then Saj finished off by, he did a demo for us, and that sort of demo was implementing VNet peering. So this is now part 2 of that topic. So we're still on the designing and implementing VNet connectivity topic of Module 2 of the AZ700 series. So let's get started. So, as I mentioned, still on Module 2, so designing and implementing core network infrastructure. And this is part 2 of that design and implement cross VNet connectivity. So today, we are going to cover force tunneling, or configuring force tunneling. We're going to talk about diagnosing and resolving routing issues. Then we'll look at associating a route table with a subnet, and rather than talk about it, I'm going to hand over to Saj at that point to actually do a demo around it. So the first topic, let's talk about configuring force tunneling. Now, again, you might remember from some older episodes, sometimes I like to use diagrams to try and get my point ahead and across. And this is one of those times. So if we look at this is an example of force tunneling when it's configured. So we have our virtual network there at the bottom here. So we've got our site-to-site VPN as well. That's our VPN net gateway. We have 3 different subnets now. We have subnet C, which is going directly to the internet. But what we then have is we have 2 subnets here, subnet A and subnet B, and they're paired together. And both of these subnets are we're forcing that tunneling, we're forcing the traffic down this tunnel down the VPN tunnel. And that's going via on-premises. So whereas any resources that are in subnet C are going straight out to the internet, by configuring force tunneling, we're actually forcing all traffic from subnet A and subnet B down that VPN tunnel. So let's stick with that configure force tunneling topic for a second here. As we mentioned, force tunneling lets you redirect or force all internet-bound traffic back to your on-premises location via site-to-site VPN tunnel. And that's for more than likely inspection or sort of auditing purposes. This is quite critical in sort of security requirement for most enterprise IT policies. And this tunneling, it's PowerShell only, so you can't do it through the Azure portal or Azure CLI. It has to be configured through that Azure PowerShell. And with this split tunneling type, you can redirect all traffic for specific subnets directly to on-premises instead of other subnets that continue to have direct internet access with redirection. As we saw in the diagram, we had 3 subnets. 1 was going to the internet and 2 were actually going force tunneling. There are some considerations when you're working with force tunneling as well. So the first one is, force tunneling must be associated with a VNet that has a route-based VPN gateway. So make sure you remember that route has to be a route-based VPN gateway. Your force tunneling configuration will override the default route for any subnet in its VNet. So you need to set a sort of a default site among the sort of cross-premises local sites connected to the virtual network. Also, the on-premises VPN device must be configured using a 0.0.0.0/0 as its traffic selectors. When it comes to sort of express route tunneling, express route force tunneling is not configured via this mechanism, but instead is enabled by advertising a default route via the express route BGP peering sessions. So make sure you remember that as well. So let's move on to the diagnosing and resolving routing issues before I hand over to Mohammed Sajid. So to test network communications with Network Watcher, you must first enable Network Watcher in at least one Azure region and then use Network Watcher's next hop capability to test that sort of communication. And Azure automatically creates routes to default destinations. So you can create custom routes that override the default routes, and sometimes sort of created custom routes can cause communications to fail. Now you can diagnose routing issues via the Azure portal, via Azure CLI, or through PowerShell. So let's stick with the diagnosing and resolving routing issues before we hand over to Mohammed Sajid. So we need to consider the following points in troubleshooting communication problems. So routing is based on what we call long prefix match, or LPM, among routes that you've defined. border gateway, BGP, and system routes. With effective routes, you can only see effective routes that are on LPM match, based on all those available routes. And seeing how the routes are evaluated for a network interface makes it a lot easier to troubleshoot specific routes that may be impacting communication from your virtual machine. Another thing you can check is if if you've defined some custom routes to a network virtual appliance or NVA. Your virtual appliance as the next hop type, ensure that IP forwarding is enabled. So we mentioned IP forwarding earlier, and that has to be on the NVA and sometimes on the OS as well. Also, something to consider is for sort of VNet pairing. For that to work correctly, a system route with a next hop type of VNet pairing must exist for that paired virtual network interface. And finally, through Azure, although Azure assigns default routes to each Azure network interface, if you have multiple networks and multiple interfaces attached to the VM, only the primary network interface is assigned to that default route of 0.0.0.0/0, or the gateway within that VM operating system. So a bit of a shorter episode from me. I'm going to hand over to Mohammed Sajid to do the demo. I believe today's demo is going to be on associating a route table with a VNet. So over to you, Saj.
Thank you, Shabazz. So in this demo, we're going to quickly take a look at how to create a route table and how to associate it with the subnet. So to create a route table, search for route tables and then select create. Select subscription. In this case, we're using Am IT Geek. We're using our demo resource group is the 700 resource group. The region is UK South, and you just give it a name. So demo route table 02. Propagate routes, yes or no. So for more information, select no to prevent propagation of premises routes to network interfaces and associated subnets. For this demo, we'll just leave it as default. Select next, look at your tags. If you've got any tags in your environment, or if you're using tags in your environment, define them here. If you're happy with what you've defined there, select review and create, and then just review and create what you've done and select create. So let's go to look at the one that we already done. So to associate a route table with a subnet, there are several ways you can do this. So if you look at the one we already created, select the route table, navigate down to subnets, and then from the subnets page, select associate. And in your virtual network, select the virtual network where your subnet resides. So we've got 4 networks. If you select virtual network 2 as part of this demo, we've got a default subnet and a gateway subnet. You associate it with your default subnet, select OK. The other way you can do it is if you go to your virtual networks and select the virtual network that has a subnet that you want to associate it with, select subnets. Again, the default subnet is selected here, and if you look down the options, you have a route table option, and the route table that we've created, AZ700 route table 1. You can select the route table you want to associate it with and select save. You can also do this at the time that you're actually creating your subnet. So if you want to create a new subnet, give it a name, AZ700 subnet demo 01. We'll give it, select the default subnet range that's defined here because they won't overlap, 10.2.2.0/24. And we select on the route tables, select the route tables you want to associate your subnet with. Once you're happy with everything you've configured, select save. And after a few moments, you will have a new subnet created with a route table associated with that subnet. So just give it a few moments. Hopefully it won't take too long. Succeeded. So if you look at the new subnet we've created, you have a route table AZ700 route table 01 associated with your subnet. Thank you for watching. Back to you, Shabazz.
Thanks, Saj. Another really good demo, really informative and really detailed, Saj's demos. I think he's doing a great job, so well done to Saj. And that brings us to an end to this part 2 of the designing and implementing into VNet connectivity topic. We've got one more episode left within this topic, and and then after that will be the last episode of module 2, which is going to be about monitoring networks. So again, you can see in the description, you'll see the link to the GitHub repository. You also see mine and Saj's socials. So please do follow us and give us a like or a comment. Please like the videos. You know, we've put a lot of effort into this series to help people. I hope you are enjoying them. Please do give us a like. And give us a comment if there's anything that you feel that we're missing or any productive feedback. And finally, please do subscribe so you can keep notified around other topics and other videos that I'm creating. So thank you for watching, and until next time, goodbye.